Hello, in this module number 3 of Introduction to Finite Elements, we concentrate our attention on finite element basis functions, sometimes also called finite element shape functions. As we discussed before, the finite element method is a numerical approximation technique that uses the variational formulation of a problem in a constructive way to obtain approximations to the solution of the problem. The Ritz and Galerkin methods are predecessors of the finite element method, and they have a great deal in common with the modern finite element method. However, in those classical techniques, the so-called test functions, functions V, that went into the variational formulation, were essentially created by the analyst in such a way that they belong to a set of admissible functions, and they represented the solution or the approximate solution over the entire domain. The finite element method takes a different approach in the sense that first, the domain of interest is subdivided into finite elements, into contiguous finite elements, and then functions are selected to go into the variational formulation that are valid at the element level. So by focusing on piecewise functions of compact support that are constructed at the element level, and then assembling these together to produce global finite element basis functions, one can then produce a linear combination of such functions and to introduce into the variational formulation in such a way that by carrying on the procedure, the result is a collection of linear algebraic equations that then can be solved by standard methods. So we focus in this session on the construction of finite element basis functions.